Hello students, today we will study unit number 4, which is electrical machines. So in this video we are going to understand the construction and working of capacitor start, capacitor run, induction motor. So I hope you are ready with your pen and paper. So without wasting much time, let us start this video. So this motor is also a type of a single phase induction motor. And in this motor, two capacitors are used, say C1 and C2. With the help of C2 capacitor, initial torque is given to this rotor so that rotor will start to rotate with the help of C2 capacitor, so that it is known as capacitor start motor. And once that rotor will start to rotate, after onwards its motion is continued, or its motion or that rotor will run with the help of C1 capacitor. That is why it is known as capacitor run induction motor. So now how it will be started, how it will be run with the help of this two capacitor, that we'll understand in this video. So first of all, we'll discuss about the construction. So in the construction, we can say that it has two windings. Say that is known as main winding and that is starting winding. Both of the windings are connected parallel with each other across one voltage source V, which is single phase AC supply. So supposing from the voltage source I current will come. So at this junction, what's happened? Current will be divided. Say from this branch, IS current will flow. IS means current flowing from secondary winding, and from this branch, supposing IM current will flow. IM means current flowing through the main winding. Now, with that starting winding, C1 and C2 capacitors are connected in series. But C1 and C2 both capacitors are connected in parallel, and this parallel combination is connected in series with this starting winding. And with that C2 capacitor, centrifugal switch is connected in series. That centrifugal switch is an automatic switch, and normally that switch is in closed condition. When rotor will start to rotate up to its 70% speed from its normal speed, then this centrifugal switch will be open, so that C2 capacitor will be disconnected from this main circuit. How? That each and everything we will discuss. So now that main winding is designed in such a way that it has a high inductance and low resistance. So that will become our what? Our series LR circuit. And for the case of series LR circuit, we know very well one thing, that in series LR circuit, whatever current is there, flowing current is how much IM current is there, that will lag behind the potential in series LR circuit. Similarly, that starting winding is designed in such a way that it has low inductance but high resistance, and that starting winding is connected in series with this parallel combination of the capacitor. That means this portion is known as what? It is known as series LC circuit. That is L, and that is combination is in series LC circuit. And for series LC circuit also we know one thing, what? That current leads the potential. Starting winding current is flowing, series LC means current leads the potential by some phase. Okay. Now that is all about, and inside on, and that is all about the stator. Now inside of that, rotor is there, which is cage rotor. Okay, now we'll start with the working principle. So in the working principle, we can say that the current which is flowing from the main winding, which is IM, that will lags behind the potential. That current, that is potential, lags behind the potential, say phi m phase. Similarly, the current which is flowing from the starting winding, say IS, that will lead the potential, say by phi s. So what's happened? This type of two current we will get. So between two current, phase difference is there, alpha. And if you want to find out the resultant current, so you will draw the parallelogram and you will find out the resultant current. So now due to this current, according to the Faraday's principle, magnetic field is produced, and direction of magnetic field will be like this. That is the direction of magnetic field. And due to this magnetic field, we can say that magnetic force is created. And due to that magnetic force, what's happened? Over here, rotor will start to rotate. How? That direction of magnetic force is this, like this. Magnetic force will be imparted on the rotor. So rotor will start to rotate. That means initially rotor will get some torque. With the help of what? With the help of this C2 capacitor, which will start the rotor. And once rotor will achieve its 70% of its normal speed, then that centrifugal switch will be open, so that now that C2 is separated from the main circuit, and after onwards, as this rotor is rotating, so that C1 capacitor will run this rotor, so that combinedly we can say that that is the working principle of a capacitor start, capacitor run induction motor. So this is all about the working principle. Now we'll understand its torque speed characteristics. So over here speed, and over here percentage of full load torque is there. So two different graphs are there. That first is for what? Capacitor start. For capacitor start, maximum load, or you can say initial starting torque, is around 150, you can say, to start the motor. And for the capacitor run, initial torque is around 350% of its full load value. And after that, as speed is increasing, torque is also increasing, and then up to its maximum breakdown value, torque will try to reduce, and it will become zero when synchronous speed is equals to actual speed of the rotor. Okay. Now this type of motor will provide high power factor, as it is capacitor start and capacitor run. So due to that, whatever operation is there, that operations are smooth, and that type of motors are used for the high capacity machineries. Like application, if you talk, so it is used for compressor, floor mills and mixture grinders. So इस वीडियो में बस इतना ही. Till then, read hard, work hard. Thank you very much.